Hey everyone, welcome to 197 Concepts. So in this video, I will be discussing you with how to check if the given string is a palindrome or not using the 8086 microprocessor. Okay, so for virtually simulating the microprocessor, 8086 microprocessor, we are going to use the software DOSBox, and you might be able to see the program right in front of me. But before going into the program, you have to know what is the meaning of palindrome. Okay, so palindrome is nothing but you take a string. For example, here I have a string called as madam. You are going to reverse it. Okay, so first of all, it's madam, and then you are going to reverse it like madam. Now, when you compare these two strings, the origin string and the reverse string, you have the same thing, right? You have the same pattern, or you have the same spelling and all. So such words are called as palindrome words. Now, for a better understanding, let us take an example of laptop word. Okay. Now, when you reverse this, you get pot pal, right? Now you compare these two. So these two are not equal. So hence these are not the palindrome words. So that is the meaning of palindrome. And what we are going to do here is we are taking a string, and we are defining the length of that string. So why is this defined? For executing the loop, for comparing, for reversing the string and comparing it with the original string. And then in order to display the result, I'm going to use the byte word. Okay, just a byte. So it will be represented at 0 or 1. So 1 is for palindrome, 0 is for not palindrome. And this is the data segment part. Okay, so that's madam is a string. This is the length of that string. Okay, so madam. So there are 5 characters. So 5 times you have to reverse it and compare it. That's why I'm going to define the length, and then I'm going to define the result, so variable result, and then I'm ending the data. So that's the part of the data. And now coming to the main part, that is our program. Okay, so code segment is as usual, and start is as usual, and these two lines are as usual we are going to do. So since our our data will be stored somewhere in the memory, this has to be moved into the data segment. So directly we cannot move it. We have to go through accumulator register. That's why we are executing these two lines. Okay, then so keep in mind, we have MADAM in our data segment after execution of these two lines. Now this madam is placed at this character M is placed, say somewhere at the location of 10. Okay, 10, 20, whatever it is. Whenever I'm executing load effective address LEA command of the string, okay, that means you are going to load this value into the source index. So initial value is going to be stored as into the source index in the form of array. So 10, then next, if it is stored as 11, 12, 13, and 14, then 10, 11, 12, 13, and 14. So it's going to store in this manner in the source index. Okay. Now, in the same manner, what I'm going to do is I'm going to, so yeah, now source index is having 10, 11, 12, 13, and 14. That means MADAM, right? Now, if you observe the second line, I'm moving the value of length, that is 0.5 into BH, and I'm decrementing it as so this value will be holding a value of BX will be holding a value of 0.4. Now, what I am doing is the initial value of BX. Okay, the initial value of BX is going to be stored in the DI. That means the source index, the destination index is going to store the string's fourth value, not the fifth value, the fourth value. That means this one. So this is 04, 03, 02, 01, and 00. Okay, overall it's 5, but according to the arrays, it's 0, 1, 2, 3, 4. So this fourth value is going to be stored into the string, into the DI. So it's 04, 03, 02, 01, 00. And if you observe the BX, so it's interpret as like this str of 04. So str of 04, it's nothing but the character that is at memory location 14, which is nothing but your M. Okay, then it is again decremented. So 03 is 13 character, which is A. And if you go on like it's M. So square brackets tell that whatever value that is within the square brackets, it is an address. It's not an immediate value. It is an address. You have to go at that particular memory location in order to get your required data, right? Now, finally, what I'm doing, I'm again moving the length 05 into CX, and I'm shifting this 05 value. I'm shifting this 05 value. That means it is going to be stored in this manner 0000, and it's 0101. This is going to shift towards the right side by value of 1. That means when this is going to be executed, it's so initially it's 0000 0101. Now it will be this value will be discarded, and it will be 100. 10 will come from here to here, and then 000, like this. Okay, so it's going to shift that way. And finally, that's a complete part of that's a complete logic. Now what I'm going to do is I'm going to check the compare the things. Okay, so I'm going to compare the two strings. So for that, I'm keeping a label as check. And what I'm going to do is, first of all, the value. That means if you have observed here in the source index, what I have 10, 13, sorry, 11, 12, 13, and 14. Okay. And in the destination index, what I have is 14, 13, 12, 11, and 10, right? So this is going to be stored one by one. So 10, 11, 12, 13, 14, one by one, these are going to be stored in AL. And the same manner, the first location, address location 14, 13, 12, 11, 10, these are going to be stored in BL one by one. Now I'm going to compare these two. Okay, I'm going to compare AL and BL. Now what I'm going to do is, if both are not equal, then definitely if 10 is equal, 14 is 10 and 14 are equal, then no problem. I can proceed with the next character. If 11 and 13 are also equal, I can proceed with the next character. But if these two 12 are not equal, I can just simply cut the comparison there and jump to not pal. That means in the display, give me an output of logic 0, not logic 0, just to display the number 0, since they are not equal. So if this 12 is also equal, then I will move with 13 and 11. Then I will move with 14 and 10. All are equals. That's why I will display the value 1. So what this is telling is jump when not equal. Okay. After comparison, see the comparison. If both are not equal, that means if you get the 0 flag as uh, 1, that means if 0 flag is set to logic 1, then simply jump from here to this part. Okay, if this condition is not satisfied, you go for this step. That means first of all, you have let me change the pen. So in the first cycle, you have compared the number 10 and number 14. Now they are equal, so this is not satisfied. You are going to execute this one. So that means you're going to shift from 10 to 11 in the source index, and you are going to load that in AL. Along with that, you're going to shift from 14 to 13, and you're going to load that in BL. Again, you are comparing AL and BL. Okay, so again, this will be not satisfied because I have given a palindrome word. So this one will be not satisfied. Again, these two will be executed. After executing, it will check the loop. Okay, so it will check the loop. And if my count register CX is not equals to 0, then definitely this will go back to this area. Okay, and that's what I have told you. It will increment the DI and SI. It will increment the DI and SI, and then it will load the corresponding values in AL and BL, and then it will do the comparison. it will again check this condition. If it is satisfied, it will simply go here. If it is not, then it will go here. It will execute this line and this line. Finally, when your count CX register after doing all the five, that means after at the last when comparing 14 and 10, definitely our CX will be equals to 0. In that case, when you come here, when you come to this line, what it does is it checks the CX register. Since CX is equals to 0, that means I no more need to go back here. I will just proceed to this part, and I've successfully compared all the characters individually. Since both are same, then I will give the output as logic 1, because this will tell that my result is palindrome. Okay, my result is palindrome. And then finally, what I'm doing, yeah, if you come here, what this does is you're going to display the result, and then definitely it has to come here. There is no need to execute these lines. Okay, so that's why I'm making a unconditional jump here. So there is no condition linked to this. After executing this line, definitely the program has to come directly to this part. There is no reason, there is no need to execute these two lines. Okay, so that's the whole program. I hope you have understood the program. Now let us try this in the DOSBox. So yeah, and I need to copy this. I have copied it. Now DOSBox. So edit, and I have pasting the program code here. Right now, 5, save as pal dot asm. So exit. Now MASM pal dot asm. So no errors. Next, what I'm going to do is I'm going to link it, and pl dot obj, and finally AF Debug pl dot exe. So this is the execution part, and I will go step by step. Hope you are familiar with this. So AX 1831 is going to be loaded in AX. Observe the zero flag. Let me just move to the full screen. Okay, right? Now, if I move the AX into the data segment, the 1 and 2 columns, the second row and the first column, and the bottom right of the screen will be updated with the data that I have. So, madam, okay. Now, load effective address into SI. So, SI initially it is 0, now it will be 0. But BX will be loaded with 0005. And now the BX is going to be decremented by 1. And this value is going to be loaded in DI. So, that's DI is updated with 004. So I'm reversing it. So CX is 0005, and it is going to be shifted. If you observe here, so 5 last it was 0101, and after shifting it to the right side, what I'm getting is 0010. That means 5 will become as 2. So that's what it has become. And now I am loading AL with the SI. So 00, oh yeah, 4D. So if you have observed the data in the bottom side, so 4D was the first source index, and it is 1840 now. And now BL, I believe it's going to be B8. No, it's going to be again 4D. Because it is of the same character M and M. The last character of the madam is again M, so that's why it's loading the same value 4D and 4D. Now comparing AL and BL, so observe the zero flag. Now it is 0, but Since both are same, the zero flag is been activated as logic 1 because the comparison result is 0. J and Z is not satisfied in this condition because what it is telling, jump when the result is not 0, right? Jump when the result is not 0, but our comparison result is 0. So this is not satisfied. But as this is not satisfied, the program will continue the execution and SI and DI will be incremented. DI will be decremented because SI will be incremented from 0 to 1, but the DI is having the maximum value. Hence, it should be reduced now. So that's why we have written decrement DI. Then next loop back to the 18th level, that is our comparison. Now AL will be loaded with 41 and DI will be loaded with, since it is A, again it will be loaded with 41. Okay, now these will be compared. Again, zero flag will stay as 1 and SI will be updated and DI will be decremented. And again, loop comparison will take on. So 44 will be compared. So it has just jumped to the last part. Okay, and it tells that, so here's the complete program execution. But if you want to see the output, what you have to do is you have to come here. That's a logical analysis, okay? That's a debugging window. You won't get the final result there when you're comparing the strings. So here, what you have to do is you have to type pl.exe. When you enter it, oh, I believe it has rebooted itself. Okay. So let me see this. Now to see. Okay. Now CD to 8086. And now MASM pl.asm and link pl.obj. Okay, and finally what we have, yeah, pl.exe. So no, it's not giving us the result because we have not executed the int21h experiment, int21h. So for that, I'm going to change the code a little bit so that we can see the output within the debugging window. Let's go to DOSBox again. Now what I'm going to do is CLR and mount C and CD to C, right? Now CD to 8086. Now edit pl.asm. Here what I'm going to do is let me try this. Move es comma result and here also move es comma result and then here move ax comma 09h and int 21h. Let me see it once. Let me try this once. So save, exit. Now MASM pl.asm then link pl.obj and now Of course, we have seen the P, what we say, the debugging part. No, so it's better if I just try the debugging screen. Okay, to get the result, try the debugging screen. So here, what I'm going to do is simple. Instead of doing all these, let's say dx. I have not used a dx, right? So I'm going to keep it as 0, 1 and jump to done. In the jump, I'm going to remove these two lines, and here I'm going to write dx comma 0, 0. Okay, and now I don't need this one because I'm not using this result variable. So simple, that's it. I'm placing it, leaving it, exit. Now again MASM pl dot asm. Okay, now link pl dot obj and AF Debug pl dot exe. Now since it is palindrome, okay, it will be executed. So 4D. Now the next is 41. Okay, the first character is compared. Now 41 again. Okay, it's comparing only 2 to 3 words, and you have seen that dx is updated as 0, 1. So that tells us our word is palindrome. But let us try like this. Laptop, and the length is 6. Okay, now if I save this and again MASM pl dot asm, no errors, linked pal dot obj and AF Debug pl dot exe. So after the execution of first two lines, 44C, 41, 50, 54, 4F, 50, 06. Okay, so all these are other numbers. Now there will be a difference. If you observe here, first of all, source index is loaded, px is loaded with 6, decrement bx. Now effective address of bx is loaded in di, and 6 is loaded in cx. That's okay. It's shifted to 3. So I'm just taking 3 times loop. Okay, I'm taking 3 times loop. Now SI, the very first is 4C. Now DI, BL has to be updated with, I believe, 06. No, 50. So 06 is the end of the string. So it is loading with 50. Observe the 0 flag here. Since the comparison is not satisfied, so both are not equal, then the 0 flag will remain 0 after executing the compare. Now, in the very first letter itself, these are not same. So definitely this condition is satisfied, and we will go directly, we will jump without executing the other next steps. We will directly jump to the variable 002a. Okay, that is nothing but the end of the program. So dx will be updated as 00, and it's the end of the program. So that's how it tells us that your given string is not palindrome. Okay, hope you have understood the program. So in that way, you can check whether the given string is palindrome or not. That's it for this video. Thank you.